Hello students, it's Nazia Begum here, your physics lecturer, welcoming you all in today's lecture. Today we are going to discuss the topic fringe width. Okay, we have already derived the formulas for position of minima and maxima, that is bright fringe and dark fringe. Now, what is fringe width? So fringe width is the separation between two successive bright or dark fringes. So let me explain you with the help of diagram, then it will be more clear. Okay, so here in front of you can see that some fringes are there. Okay, bright fringes and dark fringes. Okay, so here these are the dark fringes and these are the bright fringes. Now if you have to find out the width of a bright fringe, okay, so this is the bright fringe, this one. If you have to find out its width, then its width is from here to here. Okay, this is the boundary of this dark fringe, this is the boundary of this dark fringe. Okay, so if we find out the distance between two successive dark fringe, we can find out the width of bright fringe. Similarly, if we find out the distance between two bright fringes, okay, this is one bright fringe, this is one bright fringe. If we find out the distance between two bright fringes, we can find out the width of one dark fringe. Okay, so it is written here, fringe width is the separation between two successive bright or dark fringe. So when we have to find out the width of bright fringe, we will find out separation between two successive dark fringe. And when we have to find out the width of dark fringe, we will find out the separation between two successive bright fringe. Okay, so here you can see width of dark fringe. When we have to find out, we will find separation between two consecutive bright fringes. Okay, so for bright fringe we are having formula d lambda upon d. Okay, so if two successive bright fringe is there, suppose one fringe is at position xn, so second will be in the position xn minus 1, just before n. Okay, so here by putting n and n minus 1, we are having this equation. Okay, so this is nth position of bright fringe, this is n minus 1 position of bright fringe. Okay, so here when we open the bracket and solve it, we get d lambda upon d. So this is the width between this is the separation between two consecutive bright fringe, and this is only the width of the dark fringe. Okay, similarly, if we have to find out the width of the bright fringe, so we will find out separation between two consecutive dark fringes. Okay, so here we have the formula 2n plus 1 d lambda upon 2d minus 2 n minus 1 plus 1. Okay, in place of n we have put n minus 1. So this formula here, it will take this form. In place of n here we put n minus 1. Okay, and by opening the bracket and solving it, again we are getting d lambda upon d. So in both the cases we see that the separation is coming same. That means we can have one general formula for the width of bright fringe and dark fringe. Okay, so here is that general formula, beta equals to d lambda upon d. Fringe width is represented by beta, which is equals to d lambda upon d. Now here you can see that fringe width only depends on the distance between slit and screen, the distance between two sources S1 and S2 and the wavelength of the wave lambda, but it is independent of n, that means order of fringes. So when we say that it is independent of order of fringes, it means whether it is central fringe or the extreme one or from anywhere between central to extreme, okay, everywhere the width will be same. The width doesn't depend on the number of fringes, means on at which position the fringe is there, the width doesn't depend on them, that. So at whatever position fringe is there, the width will be same, that is d lambda upon d. Okay, if lambda is very very small, wavelength is small, so that time d should be larger. Okay, d should be much larger than small d, so that the fringe width beta may be appreciable and hence observable. So if we want to see a clear pattern of interference, so the value of beta should be large. To increase the value of beta, we should always have capital D more than small d. Okay, where capital D is the distance between slit and screen. So there should be a sufficient separation between the screen and the slit. Okay, D, capital D's value should be greater in comparison with small d. From the same formula of fringe width, we can also find out wavelength. Okay, so according to that equation of fringe width, if we transport some values, so we get lambda equals to b beta d upon capital D. Okay, and you can clearly see that from this formula only, beta equals to d lambda upon d, we have derived lambda equals to beta d upon capital D. Okay, so here you can find out wavelength if you know the fringe width and the values of capital D and small d. Now the next topic is conditions for sustained interference. So first of all, let me tell you what is sustained interference pattern. So sustained means the thing which is there for some long time. Okay, if the interference fringes are there visible for some time and after that they disappear, so that is not called sustained. If you want sustained interference, that means fringe width for proper time so that it is noticeable to us. Okay, so in order to observe an interference pattern, it is necessary that the positions of maxima and minima do not keep on changing with time. They should not change with time. Okay, they should be at their place. So otherwise what happen, maxima and minima of intensity will mix up to produce uniform illumination and we will not have the interference pattern. Okay, so here is the definition of sustained interference. The interference pattern in which the positions of maxima and minima of intensity on the observation screen do not change with time. Okay, where the position of maxima and minima do not change with time is called a sustained or permanent interference pattern. Now, what is the condition to obtain sustained interference? So first one is the two sources should continuously emit waves of same frequency or wavelength. Second, the two sources of light should be coherent, that is they must vibrate either in the same phase or with a constant phase difference between them. And these things we have already discussed. Okay, that if phase is different then what happened, if source is different then what happened, if the light is not coherent then what happened, that things we have already discussed. So here I am going to read the conditions simply for you. Okay, third, for a better contrast between maxima and minima of intensity, the amplitudes of the interfering waves should be equal. Fourth, the two sources should be narrow, otherwise interference will occur between waves of different parts of the same source and contrast will be poor. Fifth, the interfering waves must travel near sorry, must travel near along the same direction. Sixth, the source should be monochromatic, otherwise fringes of different colors will overlap just to give a few observable fringes. Seventh, the interfering waves should be in the same state of polarization. Eighth, to have sufficient fringe width, the distance between the two coherent sources should be small and the distance between the two sources and the screen should be large. That means capital D's value should be more than small d, which we have already discussed in case of fringe width. Okay students, this is it for today's lecture. See you in next lecture. Till then, goodbye. Take care, do some productive work, and the most important thing, be healthy, be safe.